Hi everyone and welcome to today's lesson. We are still talking about simplifying radicals. We are just talking about kind of where this skill comes into play in real life. Okay, so in other words, where would I see this in algebra, or where have I already seen this year in algebra, but maybe I could have used this skill earlier. All right, so let's start with triangles. Next year in geometry, you're going to be doing quite a few chapters on triangles, and you will need to have the skill of simplifying radicals. So let's use the Pythagorean theorem since we have a right angle or a right triangle here. Our C is the missing one. We can call the other two A and B, doesn't matter. So we have 6 squared plus 10 squared equals C squared, which is 36 plus 100 equals C squared. We've already done this year. We add those together to get 136 equals C squared. And to get rid of the squared, we square root. Now here is where we would type this in our calculator. But next year in geometry, they might ask for the answer in simplest radical form, not to the nearest tenth. So here's where the new skill comes into play of splitting 136 into two different radicals. So we want to find one that is a perfect square. I think the only one that goes into it is 4. 4 times 34. And then we square root the one that we know the answer to, which is 4. So our final answer here is 2 square root of 34. I always check to see if I can break up 34. The only things I know are 2 and 17, and neither of them are perfect squares. So this is done. I would even add a label here, centimeters. All right, let's go ahead and try another one. So this time our C is the 20, and we're missing, let's say, the A, and our B is 8. So here we have A squared plus 8 squared equals 20 squared. 8 squared is 64. 20 squared is 400. Unlike the last one, I don't add them. I subtract this time. So if I subtract that 64 from 400, I'm going to get my calculator out here to make it go a little bit faster. Give me an answer of 336. To undo squaring, I square root. And now we're going to break up 336 into a perfect square. Oh, I'm sure there's a lot of them that go into here. I could always start with an easy one. I know that I can divide it by 4. That would give us 84. I know that wasn't the biggest one. Square root of 4 is 2. So now I have 2 square root of 84, but 84 can be split again into 4 and 21. Square root of 4 is 2 again, so that's going to come out front. This would be 4 square root 21 would be our final answer, and again, a label of inches. All right, why don't you go ahead and pause here and try this last one on your own, and we'll go through the answer afterwards. Okay, 12 was the C, 6 could be the A, and we could be missing the B. So 6 squared plus B squared equals 12 squared. 6 squared is 36. 12 squared is 144. Just like the last one, we have to subtract the 2. B squared equals, if I do 144 minus 36, is 108. And then we need to get the square root of that. So I am going to break up 108 into 2 square roots. I can divide 108 by 36, I think is the biggest one. So 36 times 3 gives us 108. And the square root of 36 is 6, and I still have a square root of 3 left over. Put my label of centimeters. That is how you answer these types of questions in simplest radical form. All right, so that was the first objective that we covered, is applying simplifying radicals to the Pythagorean theorem. Now we're going to talk about the quadratic formula. That is another place that we have seen square roots in. So if you remember, the quadratic formula was negative b plus or minus the square root of b squared minus 4ac all over 2a. And a quick refresher, if you don't remember what the quadratic formula was for, the quadratic formula gave us the two answers of where a parabola crossed the x-axis. Sometimes we said where it hit ground level. All right, so before, I told you to leave it like this, or we even plugged it in our calculator and I showed you how to plug this into your calculator to get estimations. We are now going to apply what we know about simplifying radicals to this. Okay, so square root of 8 can go further. I can break it up into the square root of 4 and the square root of 2. Square root of 4 is 2. So square root of 8 is 2 square root of 2. Now the only thing is I'm going to rewrite what's in front of it. So negative 2 plus or minus. And then on the bottom I had 2. Now that's not as far as it can go in simplifying. Because what I'm going to do is I'm going to look at the three outside numbers. Remember, you can simplify outside with outside and inside with inside, but you can't do one outside, one inside. So I'm not going to mess with the square root of 2 since that's inside. But the three numbers on the outside, I need to simplify them. I can divide them all by 2. So if I do that, I'd get negative 1 plus or minus 1 square root of 2 all over 1. Now, I don't really need to divide or multiply anything by 1, so I'm going to get rid of some things and clean it up. 1, I don't need the denominator. So this would be negative 1 plus or minus, and I don't need 1 times the square root of 2. I just need the square root of 2. That would be our answer in simplest radical form, cleaned up. Okay, so let's try a few more examples like this. So one of these is already as simplified as it can be. And that one, if I look at 18, 20, 32, and 6, the only one that can't be divided by perfect squares is this bottom one. Can't divide 6 by anything other than 2 and 3, and neither of those are perfect squares. So that one is done. The other ones all need to be simplified. So let's look at what that means. We can break 18 up into the square root of 9 and the square root of 2. Square root of 9 is 3. So here, I would still have negative 3 plus or minus out front. And then I'd have 3 square root of 2 all over 6. Okay, I look at my three outside numbers and see if I can clean them up. They're all divisible by 3. So I'm going to get negative 1 plus or minus. I don't need 1 times the square root of 2. I can just put square root of 2. And on the bottom, I'd have 2. That is our answer in simplest radical form. All right, let's do the next one. 20 can be split up into square root of 4 and square root of 5. Square root of 4 is 2. So this would be 8 plus or minus 2 square root of 5 all over 4. And again, I'm going to look at the three numbers on the outside. They're all divisible by 2. So that would give us 4 plus or minus. Don't need to put 1. I can just put the square root of 5 all over 2. Now somebody in class asked a really great question. They asked if I could take that further. And the answer is no. They wanted to do 4 divided by 2. The reason why you can't is because technically I have a 1 there. And if I'm looking at the three numbers, 4, 1, and 2, I can't divide them all by 2. So that's kind of a tricky part. Don't divide that 4 and the 2 because of that imaginary 1 there. All right. Next one, we're going to break up 32. 16 times 2 is how we can do that. So square root of 16 is 4, and then we have the square root of 2 all over 6. I look at the three numbers on the outside, 5, 4, and 6. I can't divide them all by something, so that's just my answer on that one. All right, go ahead and try these two on your own, and I'll go through the answers with you afterwards. All right, let's start with the first one. Let's break up 108 into the square root of 36 and 3. That would be 6 square root of 3. I look at the, oops, sorry. If I look at the three numbers on the outside, I can divide them all by 2. That would give us 3 plus or minus 3 square root of 3 all over 2. All right, next one. 180, I believe, is divisible by 16 as well, or 36, maybe 36. Yep, 36. 36 times 5, that would give us 6 square root of 5 all over 6. These also are all divisible by 2, and that would give us 4 plus or minus 3 square root of 5 all over 3 as our final answer. Okay, so now we have learned how to simplify kind of our answers to the quadratic formula. Let's try to apply the whole quadratic formula. Okay, so if you remember, the purpose of the quadratic formula was to find where parabolas hit ground level, or where it crosses the x-axis. Okay, so here we have a quadratic, and I'm trying to figure out where is it going to hit ground level. Okay, so I'm going to use the quadratic formula. Remember, the formula is negative b plus or minus square root b squared minus 4ac all over 2a. So first thing I would do is figure out your letters. So a is the number in front of x squared. In this case, it's 1. B is the number in front of x, so 8. And c is the constant all by itself. All right, so let's plug it in. We've got negative 8 plus or minus the square root b squared is 8 squared, or 64. Now here's why I like to go out to the side. So when it's negative 4ac, it's negative 4 times a, which is 1, and times c is 4. That would be, if we multiply all three numbers, negative 16. All over 2 times 1, which is 2. All right, so now I've got to clean this up. I've got negative 8 plus or minus the square root. Let's figure out what 64 minus 16 is. That gives us 48 over 2. And here's where I'm going to split up 48. I think 48 is divisible by 16, so 16 times 3. So we're going to take the square root of 16, which is 4, times the square root of 3, all over 2. And I can simplify all three numbers on the outside by dividing them by 2. Final answer here would be negative 4 plus or minus 2 square root of 3, and I don't need to put over 1. That would be my final answer. All right, let's try one last one together, and then you can try one on your own. So again, here's the quadratic formula. And we're going to figure out our a, which is 3. Our b is negative 9, and our c is 1. All right, first things first, let's make sure we plug it in correctly. So negative b, since our b is negative 9, we're going to make it positive 9. B squared, negative 9 times negative 9 is 81. And out to the side, I'm going to do negative 4 times a times c, and that would give us negative 12 there. All over 2 times a is 3, so 2 times 3 is 6. Let's get inside the square root. 81 minus 12 gives us 69 all over 6. And we see if there's a perfect square I can divide that by. It's not divisible by 4. It's not divisible by 9. It's not divisible by 16 or 25 or 36. So if it's not divisible by anything, that's your answer. All right, go ahead and pause here and see if you can get this last one. All right, let's see how you did. So first off, let's identify them. A is -1, B is 6, and C is 3. I'm missing an equal 0 there. All right, so our negative b is -6 plus or minus the square root. Our b squared is 36. Now to the side, I'm going to do -4 times -1 times 3. This time, I'd get a positive 12, so I'm going to put a plus 12 there, all over -2. We're going to clean that up, so -6 plus or minus, that would be the square root of 48, all over -2. If I split 48, that would be 16 times 3, which is 4 square root of 3. All over -2. And I can divide them all by 2. So in this case, it would be -3 plus or minus 2 square root of 3 all over -1. Now, anytime we see a lot of negatives, we usually try to divide it by a negative as well. So if I divide them all by a negative, this is what's going to happen. -3 divided by -1 is +3. And then I have a plus or minus here. That plus or minus means both a positive and a negative. If I multiply that 2 by a -1, it's going to change it from a positive and a negative to a negative and a positive. In other words, it's not going to change anything because it's already both signs. But the reason why we like to do that is because it cleans up all those negatives. It's like when you divide a negative by a negative, it's better to write it as a positive. And so this is the exact same thing, it's just a little bit more complicated. So we want to get rid of those negatives if we can and clean them up to the positives. So this would be the better answer for that one. All right, that's it for the notes today. I hope this was helpful. If you have any questions, don't hesitate to send me a message. All right, thanks. Bye.